This is Unit 6, Section 4 notes. So now we're going to move on to graphing radical functions. Now we're only going to graph square roots and cube roots. Don't want to get too crazy. So that's it. Let's do the first one, graphing square root functions. Now before we do any of the example, let's go ahead and make some notes below here. So just some things you need to know before this all makes sense is you want to know the parent function. So parent function for a square root. So parent square root function, however you want to write that. So parent square root is y equals square root of x. No numbers, nothing else, right? That's it. Okay, now, since we're talking about graphing, that's the function. You gotta know what it looks like. So real quick sketch, if I just draw a graph right here, a parent square root function starts right on the origin, right in the middle, and it goes up to the right like that. That's what it looks like. Okay, I'll go through the specifics on how you find all the different points you need and everything. But generally that's just what it looks like. The normal one goes up to the right from a single point, and that's it. Okay, so it's kind of like half a function. Alright, so domain for the normal function is just going to be x is greater than or equal to 0. And the range for this one is y is greater than or equal to 0. Okay, now off to the side if you want to, and we'll talk, this will make more sense here in a minute. So domain is greater than or equal to 0. Most of the time, I won't say always, but most of the time, at least for this class, your x is going to be greater than or equal to whatever h is. So you remember hk, we'll talk about that. And then y, so if I have a positive, so positive square root, then I will have y is greater than or equal to k. If I have a negative square root, then of course it'll be less than or equal to k. Okay? So hk will come into play with all of these. Okay, they'll help you find a lot of things. So, but for the parent, the basic one, it's just 0 because your h and k are 0. Alright, next thing. For this one, notice we have a point, and then the graph, the line just shoots off from that point. That means we have what's called an endpoint, because we have an end to this function. So my endpoint for this one, the parent, is 0, 0. Or off to the side, it's just going to be h, k. So see, hk comes in quite a bit. And then last thing on here, well, second to last thing. So we have end behavior. We've kind of talked about end behavior before. It's been a while. So for end behavior, we have one end, right? And this will make sense when we do it. One end approaches h, right? The endpoint. So, oh wow, that's not how you spell it. So one end approaches the endpoint, so you're going to use hk. And if you want to write hk, that's fine. So one end approaches the endpoint, one end approaches either positive or negative infinity. It just depends on where it goes. Oh, why do I keep doing that? I don't know. Approaches either positive or negative infinity. Okay? And again, when we do the problem, this will make more sense. It's just if you have it written out, you can read it and go, okay, yeah, that makes sense. So instead of just showing the example with nothing else, that doesn't help. But if you're able to read words that explain what we're doing, I think that helps a lot, so that's why I do that. Okay, and then the last ones we have increasing, decreasing. So I like to just abbreviate increasing and decreasing. Ooh, whoa. So increasing, decreasing intervals. So for radicals, for square roots, you can only do one. So you only have one or the other. You don't have both. Okay, so only have one, never both. Wow, okay, I don't know what happened there. Let's erase that. Okay, because if you look at the graph, now if you're still writing, that's fine. So if you look at the graph from left to right, this graph is only going up, right? So I'm always increasing on this one. So I can only always increase or always decrease, okay? So for that one, you can write it, so it's usually going to be, I don't know how to put this. So most of the time, for square roots, you're going to have, it'll be a bracket, and then whatever your h is, and infinity for increasing, right? So let's write that on there. And then if I'm decreasing, it's going to be bracket h and then negative infinity, right? That's because I'm going down. So those are my two options for this function. So if I'm increasing, I'm h to infinity. If I'm decreasing, actually no, that is wrong. I'm thinking of y. Never mind. Thinking the wrong thing. So you're going to write, sorry, my apologies. If you need to erase or whatever, that's fine. So no matter what, you're going to write. So 1 equals 1, meaning increasing or decreasing, is h to infinity. I'm thinking, yeah, because x, right? And then 1 will equal what's called d and e, which does not exist. If you want to write that out, you can. So does not exist. So because I can only have increasing or decreasing, I can't do both. I'm going to have one of them that has an interval. The other one does not exist because it's not possible. I can't do both at the same time. I can't go up and down. That just doesn't happen. Okay, so sorry about that, but so one of them is an interval, one of them is d and e, does not exist. Alright, I know that some of that might seem confusing, but hopefully now that we do the example, it'll make a little more sense. So let's go up here and look at the function. As soon as it loads on mine, of course paper, if you have it, it's just there. Okay, so when I do this, we have our square root and then we have our two numbers, right? So we have hk. So real quick about hk, if you don't remember, h is always with x, k is always not with x or outside of x. So if you need to write that somewhere, however you want to write that is fine. So notice my 3, right, my plus 3 is under the square root with x. That would be my h. And then my minus 4 is outside the square root. It's not with x. That would be k. And then like always, my h always flips signs. So if you want to write h is negative 3, k is negative 4. So if you need to write it out, that's fine. Do that. If not, just remember you always flip h. That still applies. Okay. So before I graph anything, let's fill out all this information. So for domain, remember that's going to be h or x, sorry. X is greater than or equal to h. So for this one, I have x is greater than or equal to, well, h is negative 3. So I'm going to write negative 3, and that's it. Range, very similar. Y, now let's look at this. See my square root right here? There's no negative in the front, which means it's positive. So if you're looking at the notes, because you can see the whole paper, I cannot right now. If you have positive, it's greater than or equal to k. So I'm going to write y is greater than or equal to k, which is negative 4. So that's my domain and range. Okay, my endpoint slash turning point. So on these, you actually want to circle the correct one. So because it's a square root, we have an endpoint. I'm just going to cross this out. You don't have to, but so you'll circle the right one. On the cube root, we have turning point, which is why there's both. So you have to know which one is which. And then, of course, if you're looking at the notes, our endpoint is h comma k. So my answer would be -3 comma -4. So far, hopefully it's not too bad for you. Yeah, it's not too bad. All right, in behavior. Okay, so in behavior, if you look at the notes, because again, you can see the whole page, I cannot. You have one end is always approaching the endpoint. So our endpoint is -3, -4. Okay? So on this one, we're going to have h and k. They just go in order, right? Because it's always x, y. And plus, this says as x approaches. Well, if we're talking about x, we're talking about h, which is -3. So as x approaches h, which is -3, y, or f of x, approaches k, which is -4. So really, if you just remember that whatever my endpoint is also goes for my end behavior on the first one, and they go in the same order, that's all you got to know. Okay, so that's one end. The other end, okay, if you're looking at your notes, always approaches positive or negative infinity. Well, because we have a positive square root, I would go to positive. If, just real quick, let me show you. If there was a negative out here in the front, so if I had like a negative square root, which you'll see on the homework, negative square roots would go to negative infinity. Okay? So on here, I'm just going to put as x approaches infinity, infinity. Okay, if it was negative, it'd be infinity, negative infinity. So that's pretty much it for end behavior. And if you want to, for this class, it's not always true, but for here, this first one will always be infinity. So the h, k, infinity, those will never change for all of this homework and stuff. The only one that could change is this one. So if I have a positive square root, it's positive. If I have a negative square root, it's negative. Okay, so those three will not change. Now, last two things is increasing and decreasing. So I have to write something next to those. Alright, so if I am looking at my notes that you have written below, if you wrote them, great. For one, well, I can only have one of them, right? So just looking at the square root, I am positive. So again, if I have a positive square root and I'm going to positive infinity, that means I'm probably going to be increasing. So if I am increasing, what am I not doing? I'm not decreasing. So for decreasing, I'm going to write does not exist, D and E. That would be my actual answer for that one. Okay, so the one you are not doing does not exist. The other one that you are doing, remember, will be your bracket h infinity. That's how you write it. So of course, since we already have h, I'm going to write bracket. My h is -3, and then infinity. Okay, so that's what your answers should all look like. And again, the green, minus that arrow right there, all the green parts don't ever change. Except the increase and decreasing, that interval can be on decreasing or increasing, so it's not always on increasing. But that's how you would always write it. And the only other one that could change is my range. If I had a negative, that would just be less than k. Other than that, though, that's the general format for all of these answers. So they're pretty consistent. And again, if you practice these, they'll get easy. All right, last thing I got to do is actually graph this thing, okay? So I kind of use my answers to help me out. First one is my endpoint. That's where I want to start. That's the point that my graph starts and goes from there. So if my endpoint is -3, -4, I'm going to go down here and graph -3, -4, right here. Okay. Now the other thing that might help me is, do I go up to the right or down to the right? Okay, you can go left on these, but again, for this class, you will not do that. I did not do that. So don't ever go left for the homework or the quizzes or chat. Don't do that. Okay, so I am going to go to the right. I just have to know, do I go up to the right or down to the right? Well, if you look at increasing, decreasing, I am increasing, right? Which means I'm going to go up to the right. So here's the pattern. There is a pattern for these. If you remember the parabola, the quadratic, remember how we would go over 1 and then go up 1 squared, and then we go over 2 and then up 2 squared, and so on, like 3 and 3 squared? This is the exact same pattern, except instead of going over and up, I'm going to go up and over. So let me show you. From my point, I always start from the point. If I go up 1, so I go up 1, I'm going to go right 1 squared. Okay, there's a point. Then if I go up 2, I'm going to go right 2 squared, which is 4. So 1, 2, 3, 4. There's my point. And then the next one that I could probably do, I won't always be able to do 3, but you should at least be able to do the first 2. If I go up 3, I'm going to go right 3 squared, which is 9. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my third point. So it's just like a quadratic, it's just turned on its side. So instead of going over and up, I'm going to go up and over. Or if it was decreasing, I'd go down and over. Same thing. Okay. Now, so from, I can't go 4. I can't, because if I go up 4, I have to go over 16. I don't have that room, that space, so I don't have to worry about that. So all I do now is connect my dots. So if I connect my dots, that's what it looks like. And again, because I'm only increasing, I don't have a bottom part to my graph. I can't do that. Now, don't write this, but just let me explain why. The reason I only have half of a line or half of a graph is if I went down like this, then all of a sudden I'm not a function because I would not pass the vertical line test. So that's why you can't do both parts on a square root. That's also why a square root cannot equal a negative number when you're talking about functions, because a function can't have two y's for the same x. So you should only have either going up or only going down, and that's it. I know that was a lot. I apologize. Hopefully the next one, let's do the next page, is cube roots. Maybe now this one might be a little easier to do. So some notes real quick. Let's do parent cube root is going to be y equals, of course, cube root of x. That's it. No numbers, nothing else. So the graph for this one is very identical, very similar. So it's kind of like this is how I always write these. Oh, go away. I start from the center and I would go up to the right, just like a square root. But because cube roots can equal negatives, then I would kind of go the exact opposite direction. So I went up to the right, now I'm going to go down to the left. That's what a cube root function looks like. Okay? So a cube root function goes the whole way across. So just a few things on this one that you need to know. So we have domain is all real numbers, because I'm all the way, like there's no stopping point. So this is like a normal function. My range is also all real numbers. So these are much easier. I like these. Okay, notice I don't have an endpoint, so I'm not going to write that. Now I'm going to have what's called a turning point. So my graph turns at a certain point. That's what I want to know. So my turning point for this one is 0, 0, but for all your functions, it'll actually be h, k. So we still have HK, doesn't go anywhere. Okay. Next one, we have end behavior. So for end behavior, both, well, it's supposed to be a B. So both ends approach either infinity or negative infinity. So both ends approach infinity, right? So I'll just put positive / negative, because it can be one or the other. Now, they're not both the same answer, but you have a positive for one and negative for the other. Okay, so both ends approach infinity of some kind, either positive or negative. They don't ever approach a number. Alright, last one is increasing, decreasing. So increasing and decreasing. Okay, for that, I still only have one. So only one, never both. Oh, come on. Never both. So again, I can only increase the whole time, or I can only decrease the whole time. Now, the way that you write these, always, and again, see, these are easier. Okay, so whether I am increasing or decreasing, I always am going to write it parentheses, negative infinity, comma, infinity. And again, that's one of them is that, and then one of them is D and E. Does not exist. Okay, so that's the notes for cube root. So let's do this example up here. And you might like these a lot better. They don't take near as long. I mean, I don't really think the square roots do either once you kind of know what you're doing. So the first thing I'm going to do is label. We have H and K. So H equals positive 2. Remember, H flips. K equals positive 3. So let's go over here. So domain and range. Well, this is a cube root function, so domain and range is both all real numbers. Always, always, never changes, okay? Endpoint / turning point, okay? So I have a turning point because it's cube root. I do not have an endpoint. And for this one, it'll be H comma K. Always, always HK. So my H is 2, my K is 3, so my answer would be 2 comma 3. Okay, so, you know, about the same as square root. End behavior. Okay, so for end behavior, I am always going to write this stuff. So I'm always going to have negative infinity here and positive infinity here. So if you want to, you can always write negative infinity first and positive second. Those will always be there. What changes are the second two, the f of x for each one. Okay, so again, I'm going to have to do what I did before. I look at the very front of my cube root. Is it positive? Is it negative? Well, there's nothing there. There's no negative, which makes it positive. So because I have a positive cube root, this will be very easy. So if I have a positive cube root, they just match up with each other. So the negative infinity matches with negative infinity. And then positive matches with positive. If it was a negative infinity, these would flip. Then they'd be opposite. So negative would go to positive, positive would go to negative. That's the only difference. So if I have a positive, they match, negative, they switch. Okay? But my first two are always the same. Alright, increasing or decreasing. Well, again, I have a positive square root, so I'm going to be increasing. And I always write negative infinity to positive infinity for whichever one it is. So my answer for increasing is negative infinity, positive infinity. And then the one that I don't do is D and E. Does not exist. So see, that didn't take near as long because most of the answers are the same. You don't even have to look at hardly anything. So let's go ahead and graph this one, and this one's a little different on the pattern. So Turning point 2, 3. I'm going to go there first. So 2, 3. There's my turning point, which is the middle of my graph. Now, the square root, we would go up 1 and then right 1 squared, up 2, right 2 squared. Okay, now because we're doing a cube root, that is to the third, it's kind of the same thing as the square root, but instead of going up 1, right 1 squared, it's up 1, right 1 cubed. So we just change the exponent. So if I go up 1, 1 cubed is 1, so I go right 1, there's a point. So then if I go up 2, 2 cubed, remember 2 to the third power is 8. So I would go all the way over here. There is my second point. Now, the nice thing about this one is I can usually only do 2, because if I do 3, it's 27, and these graphs don't go that far at all. So on a cube root function, you will only have to worry about the first 2 points most of the time. Now, because it's a cube root, I don't only go up, I also go down. So I went up to the right, now I go opposite, down to the left. So if I go down 1, I go left 1 cubed, sorry, not squared. And then the same thing with the 2. I go down 2, left 2 cubed, which is 8. So, come on. 1, 2, 3, 4, 5, 6, 7, 8. There's my other point. So I have these points right here, right? These 4 points. Now I just have to connect them. So whatever way is easier for you to connect these is fine. You can go all the way from the left and then go through. You can start from the center and do each one separate. It's up to you. I do each one separate from the center. I don't know why. This just seems to be easier. So I have that one, and then I have that one. So that's the graph for a cube root function. Okay. Alright, last part, and this one should be fairly simple. We've done this a lot. It's just talking about transformations. So, I guess I will go ahead and write, well, you know what? I'm not going to write the notes on the video because a lot of y'all already remember these and you don't need to write these down, which is great. If you need to write them down, you can look at the notes, the answers for the notes on Canvas. They're always up there for every section if you ever miss anything or just want to see how I've written it differently. So I'm just going to go ahead and do these. Okay, so the first one, I have, let me highlight. So I have 1/2. Okay, so I'm dividing, right? So 1 divided by 2. So for this one, I would actually write compress by a factor of 2. Okay, so that's my first one. I compress by a factor of 2. If it was a whole number, you would stretch by a factor of 2, right? Okay, and then my only other number on here is this plus 5. And notice it is outside the square root. So it's not with x. So remember, anything that's with x, or in this case, anything under the square root goes left and right. And then anything outside the square root that's not with x goes up and down. So this would be my k, right? So since my k is plus 5, my answer would be shift up 5 units. Or if you just want to shift up 5 is fine. You don't have to put the units if you don't want to. So that's my only 2 things here. So I compress by 2 because it's 1 divided by 2. And then I shift up 5 because it's plus 5 that's not inside the square root. Alright, and then the last question for today, which I know it says only 4 and it seems like a lot. Alright, so the first one. This one is negative. Now the negative by itself makes it reflect. So I reflect over the x-axis. So see, the nice thing about transformations, it's the same for pretty much every type of function that we can graph. There are very little changes, and they're not even in this class, so you don't have to worry about it. So transformations are always the same for here. Alright, the next one that is separate. Notice I only highlighted the negative. The negative is by itself. Now the next part I need to look at is the 2. The 2 is not part of the negative, so don't think of it that way. So my 2, because it's a whole number, means that I stretch. Oh wow, there's an E there. So stretch by a factor of 2. Or if you just want to write stretch by 2, that's fine with me. So I reflect with the negative, I stretch with the 2. Next one, minus 4. Notice how that's under the square root, right? That is still under the square root. So still under the square root means that it goes left and right. This is my h. And remember, h always flips, so the negative 4 actually goes to the right. I know normally minus goes left, but h flips. So this one I would do shift right 4. And then of course the last one is minus 3. That is outside the square root. That means that it would shift down. And then 3. So again, if you want all the notes for all the transformations again, if you need them, they are on the answers on Canvas. I didn't want to waste the video writing all that down because I know a lot of y'all are good on these by now. You don't need to write them down. That's great. If you have any questions or need help, please let me know.